Dear students, welcome to the lecture series of digital electronics. Today we will discuss the one important flip-flop. It is called as a D flip-flop. So remember that thing, the D flip-flop is also called as a modification of the RS flip-flop. In D flip-flop, one input is there, external input, which is called as a D. Okay, and obviously there is an output Q and Q dash. Two different type of the outputs are available. So let's see the circuit diagram of D flip-flop. Here, this up to this diagram, these four NAND gates are as a RS flip-flop which we already discussed. But here in reset and SAT, as we discussed in the NAND gate RS flip-flop, here SAT and reset. So this SAT and reset inputs are change. Set and reset, these two inputs are changed by single input. Okay, how it's look like is that this set and resets are there. So this set, it is directly connected with the D, and R is the D dash. There is one inverter in this circuit, and here D input is that. So my set is inputted D, and this will become reset is D dash. So the circuit is look like is in this way. There is a one AND gate which is work like as a NOT or inverter. So this will become D dash and this will become D. Okay. Now let's see how the D input goes directly to the set input and its complement is got into the gate number 5. This is the gate number 5, and this gate number 3 and gate number 4 is there. Okay. Let's see the behavior of the circuits with the truth table. As long as the clock pulse input at a 0, the gate number 3 and 4 have won their input. Okay, as the clock pulse is 0, the any one input is 0, the result is 1 always. So this will become Q dash and this is Q. So 1 ended Q whole bar, this is Q dash and this will become Q. So 1 Q dash whole bar is equal to always Q. So Q is remained stable. While here it is 1 dot Q whole dash, and this will become Q dash. So Q dash is also stable. So if clock pulse is 0, output stable or not change. Remember that thing. So whenever the clock pulse is 0, only when clock pulse is goes to 1, at that time the output of gate number 3 and 4, it depends on 1 D dash, and this will become 1 D dash whole dash, it will become D. So now it is depends on 1. Whenever the clock pulse is 0, the output never change during this condition. Only the when clock pulse is 1, at that time D dash and this will reflect the output according to the value of D. So let me first clear that thing. So we discuss one by one each situation. What happens if the clock D input is changed during the clock pulse is generated or clock pulse is equal to 1. So here only one input is there. So first condition is that if Q equal to 0, obviously at that time Q dash is 1 and D equal to 0. So D dash is equal to 1. Clock pulse is 1. Okay. If any one input is 0, the result is 1. 1 1 whole dash is equal to 0, and 0 1, if any one input is 0, the NAND gate output is 1. So 1. So output is 0. Now, second condition is that the D is input is 0, but D is equal to change to 1 while the clock pulses occur and the previous output Q is equal to 0. So 0, 1 is the next condition. Q is equal to 0 and Q dash is equal to 1. This condition and D equal to 1. So D dash is 0. Clock pulse is 1. Now any one input is 0, the output is 1. 1 1, the output is 0. In NAND gate, 0 1, if anyone is 0, the output is changed to 1. So now Q changed from 0 to 1. This one will be reflected here. 1 1, the output is 0 and this 0 will goes to here, but due to this 0 always the output is 1. So finally we obtain the Qt plus 1 is 1 and the complement is 0. Now let's see the third possibility, and it is Q is equal to 1 and D is changed to 0. So here the Q is equal to 1, Q dash is 0 and the D input is also 1. Always remember that thing. First you have to find out which gate input, NAND gate input is 0, because if any one input of the NAND gate is 0, the result is 1. Here 1 1, the result is 0. Both are 0, the result is 1. 1 1, the result is 0. So it 0. Okay, no, it's 1. Here there is mistake. Next is Q is 1 and D is equal to 1. So Qt plus 1 is equal to 1. Now next one another condition is remaining is 1 0. Okay, Q is equal to 1 and D equal to 0. Q is equal to 1. So first it here 1 and 0 and D is equal to 0. So this one both are 1 1 0 0 1, if anyone is 0 1 1 0 1 1 0 1. This one goes to here a momentary time period. It fluctuated, but 1 1 it will become changed to 0 and this 0, but due to this presence of second input is 0, it's 1. Finally we obtain the stable output is 0. Okay, so the clear is that here the third condition, the mistake is here, it is 0. Remaining everything is okay in this table. So what we found that from the truth table, we found that whenever the D value, whatever the Qt plus 1 is same like is D, it is not depend on Q. See, when D is equal to 1, the Qt plus 1 is 1. When D equal to 0, the Qt plus, so it's simply replicated here. So we can say that the Qt plus 1 is equal to D from this characteristic table. Okay. So it is simply can say that it is transfer the what is the input value to Q, or we can say that it is like is a 1 bit register 1 bit information storage device. Whenever clock pulse is changed to 0 to 1, in this situation, whatever the input value, it store inside this flip-flop. Okay, when clock pulse goes to 0 means the circuit is disabled and It store the previous value. It is not depend on D. Okay. Let's see. Suppose the clock pulse is continuously square wave, and my D input is, okay. Now what happens? The output Q. Suppose the Q is 0 initially, and here at this momentary time, the D is equal to 0. So obviously this will become 0. But when Q is equal to 1, at that time the D is changed here. So at that time the Qt plus 1 equal to change to 1. Now during this time it is not enable disable. Again 1, it is not change. But during the 0, here clock pulse is 0. Is it possible to change the value at this time? No, right? Because the flip-flop is disabled. It wait up to that much time. When clock pulse is equal to 1, up to that much time the D never change. It remain constant 1. But once the clock pulse is changed from 0 to 1 and value of the 1 is there, at that time it will become 0. And again, when the clock pulse is 0, it is remain stay up to the next time the clock pulse is changed to 1, and then it will become changed to 1. Okay, so simply when clock pulse is 1, the value will become changed. During this, suppose here the clock pulse is 1, during that time, suppose suddenly, okay, suppose suddenly this will become changed to 0. So immediately this will be also changed to 0. So during this clock pulse time, if input is changed, the output is changed. But if the between this time clock pulse is 0, the output never change, it is in stable condition. So this is the purpose of D flip-flop. The symbol of the D flip-flop, it's look like as in this way. It is a simple, when we design the circuit, the normally we draw the flip gate by help of NAND gate and NOR gate. But when we show the flip-flop in our circuit, it is simply one rectangular box with the indication of input and output. Okay, one input D, Q and Q dash. This is called as a trigger, positive trigger clock pulse. But here this triangle is not shown. So this is the symbol. The characteristic table is say that the characteristic equation is also derived from this truth table, and the D input, it is independent value of the present state. Remember that thing. The output is independent. The value of present state, it is not dependent on Q. It is not depend on Q. It is only depend on the value of D. The Qt plus 1 is equal to always D. And D flip-flop is normally useful as a 1-bit register circuit. So I hope is it making sense to everyone regarding the D flip-flop. Have a good day.